Hello world! Today I want to show you how I scanned this motorcycle part. I already prepared it with scanning spray because it has a shiny gray surface and that's not easy to scan. I put it on top of my raised 3D printer, add some markers to it because I will scan it in marker mode with my Revopoint Miraco in far mode. With marker mode turned on. I tried it in feature mode at first, but I didn't succeed. I tried it in marker mode with near mode and struggled also because of the narrow field of view. I lost tracking quite often and couldn't get a solid model. So let's fire up the Miraco. Start screen recording also, so you can see what's going on. This is a quite handy feature. I like that Revopoint puts this effort into their scanners. Just double check the settings and hit the play button. So now we are scanning. All the green is the 3D data that the Revopoint Miraco is scanning at the moment. You can see we have approximately 10 frames per second and tracking is quite good. Some red spots where it tends to lose tracking, but it gets it again really easy and it's no problem to move around. For best success you should be perpendicular to the scanned edges, but that's not always possible. So sometimes you have to play around with your brightness. Sometimes automatic brightness works good. Sometimes you get a lot of artifacts because of too much brightness. That are the red regions in your left camera on the left top of the Miraco. I'm sorry for the unsharp camera. I misadjusted the autofocus field. Yeah, and say hello to my neck. Here I am moving around from behind. Yeah, and you can see I put a black plate in the background with marker dots stick to it so that I can reach really deep and don't lose tracking. That's nice to catch some detail from the other side of the part. That wouldn't be possible because you always need at least, I think, 5 markers in view, and as they are all laying flat and the pyramids are really deep down, you couldn't exceed the plate. But now let's see, you can see the markers in the background and you can see that I can go really deep under the surface, turning around, and it keeps tracking really good and nicely. I really like this. The only problem I had with smaller parts and the marker mode, I can't get a good scan out of a black shiny part, even if I stick markers to it. So now I reorient the part to get it from another angle. Just use another pyramid and gently position it so that the scanning spray doesn't get wiped off. And then start over again. As I mentioned before, I didn't succeed with the near mode and the smaller part because I had to stick markers to the part, and I'm not sure how to do it the best way because I need scanning spray and markers. And so if I put the markers on and put scanning spray on afterwards, you can't see the markers, or the scanner can't see the markers. So I would have to wipe them off manually, and that would be really hard work. So the second thing, if you want to spray it with scanning spray and stick the markers on top of the scanning spray, this won't work because they don't stick to scanning spray, because it's powder, and it just sticks to the powder and the marker won't stick to the surface. So for this reason I printed the marker pyramids and different kinds of markers. I also bought reflective tape and punched my markers out of this reflective tape, because the normal markers you can buy, for me they are too expensive, and also I can get them only in the 6mm diameter, and I made myself 3 mils, 10 mils and 6 mils, and so I am more flexible with this solution, and it's way more cheap. So as you can see here, absolutely no problem with tracking at all. Gets good coverage. Yeah, I like this piece of technology. I think Revopoint did a really good job here, because fiddling around with the cable and my laptop was always a pain in the ass to me. And also the attachment for the phone, you have to prepare it, you need a power bank, and then you're scanning and someone calls you and all this kind of stuff. This is all gone with the Miraco. You just use it like a regular camera, and it works just fine. Technology wise, I think it's like the range and maybe the POP 3 in one device. I think it's slightly better than the range 1 in far mode. Near mode, from the details, the Mini is a bit better, but the Mini has his problem because of the really small field of view. You have really problems with bigger parts, and the blue laser is nice, but yeah, the small field of view makes it for me nearly unusable. I didn't get any good scan of a technical part that I like to scan, because I don't have small parts. I always have challenging parts, mostly black, mostly thin, low details, regular surfaces, these parts of things. And yeah, these are from nature, not the best friends of scanners anyway. So I have to find my way. And that's also the reason why I did this video, or why I chose to do this video, because I want to show you the full story. To get this part right, it took me nearly a week, but in the end you will see it turns out really great. And also this first scan, or one of the first scans with marker mode in far mode, turns out really good, better than I expected, honestly. So nearly finished with the scanning process. I had always a hard time with the edges, and also the alignment when I have to align the two parts. First, always I tried to lay them flat on both sides, but then I can't get the alignment right. Also with the feature mode, I put it on crumpled paper, scanned it from both sides, and get nice scans, and all seems good. But I struggle to align it properly, because you have no features, and the edges and the overlapping areas are always hidden from something of the crumpled paper, or you don't have a perfect edge on the underside, because it's not that good. So now fire up the PC, import the data from the Miraco Wi-Fi. That works flawless, easy peasy. You could do it all on the Miraco itself, but yeah, that's just a solution for outdoors. I like my computer and its power. So I crank it all down. Fuse the point cloud. Have a look. Seems quite good. Very much of the details. It's a good dense cloud. Seems promising. Let's get on. Fuse the other parts. And then clean up and make some mesh. So next part. Seems good too. Let's fuse it. Crank it all down. Speed it up. Do not bother you with my slow PC. And let's see what we got. Yeah, looks good too. Really nice scan. You see all the details what you get from the far mode. It's impressive. I am impressed. And I have to do more with this stuff to get used to it. Because always when you see a advertisement video from Revopoint or some one other, it looks so easy. You just point on it, you push it in the software, press two buttons, and you have a STL you can print. But yeah, that's not the case with this part. So this seems a bit noisy. Let's see what we get here after fusion. Same story. crank it all up, hit the button, speed up the PC. And voila! What we got here? Wow, really nice looking. You see, Revopoint did a great job with their software. They really have some magic going on. They realign some small misalignments and clean this all up. It's really good, their fusion process, and they keep improving the software really often. So I think they are on a good way. They can keep up the pace. This will be in really awesome software. So now that we have fused all the parts, let's go and clean them up. Let's cut it out. We just need the actual part. We cut it out roughly, and we don't clean it up by yet because we leave the unsharp edges, so inverse and hit delete. We leave the unsharp edges by now because we need all the data that we can get for the alignment to align it exactly, and just after the alignment is complete, we will start cleaning the meshes, or the point clouds, sorry, to fuse them later and then to mesh them into an STL. So I think you know the basic workflow with the polygon tool and the inversion button. What's nice about the Revopoint software is you have this selector where you can select if you select all through the model, so top and back face, or if you turn it off, you just select the points that are facing you. So all the blue points will be selected and the brownish points that are the back side are not selected. That's a feature. I like it. It's handy for me, and I had to find a workaround in Cloud Compare because I like to work in Cloud Compare. For me, it's a really awesome software for this type of things. But I didn't find an option to do it there, so I had to fiddle around with cutting out different sections and fusing them together again later. But it's working absolutely fine too. So the rest of the cleaning I sped up for you because it's a relatively straightforward process. You'll get familiar to it if you scan a few things, and it's really it's easy. That's not a big deal. Yeah, and after cleaning up, I export the point cloud to a specific destination so that I can open it up in Cloud Compare and align it in Cloud Compare later. Because they have a handy feature, you can manually combine the clouds with point picking, as you can do in RiverScan, but I always get better results in Cloud Compare. So let's power up Cloud Compare, open up the exported point clouds. Turn on normals. Just click on the mesh and tick the button with normals so you can see what's going on. Else they are just a bunch of points and you are not able to see anything. At first I orient the parts in the same direction and separate them from each other so that we have a better view of them later when we pick the points for alignment. Just check the quality of the point cloud. It's quite handy. So turn it with the left mouse button, with right mouse button, drag it. Take the next one with the rotate, move and rotate tool, and we're done. Now select 2 point clouds, align clouds, and now we have to pick at least 4 points in the same order that are the same points for alignment. And when first picking a point, it asks if it should calculate the octaves for you. Just hit yes, doesn't bother. The PC does the work for you. So in here you have to look for points that are visible and good reachable in both point clouds. This might be a tricky thing, especially in difficult parts like this. So on the bottom side, it's doable with all these ribs. On the top side, we have to use either the edge or the groove where the lock mechanism sits. If you're happy with the alignment, say OK. Double check if all looks good, and then we proceed with aligning the second. Yeah, no, I gave it a color to have a better look, to see where the two meshes collide, or where one of the two meshes gets through. Gives you a good overview if this could be right or not. I didn't notice at the beginning in the left top corner you can decrease and increase the point size. Would have helped here, because when you zoom in too far, points get so small you don't see much from the surface, and you don't get a feeling for where the part actually is. Increasing the point size helps here a lot. You will see it in later in the video, and another point cloud. Sorry, and another cloud compare video where I align the other clouds. So again, 4 points. Five, align, take a look, and if you're happy, click the checkbox, hit OK, and there we go. So another color the first one. So we have red, green and blue. All the RGB colors. Take a closer look. Can this be okay? Looks quite nicely. Take your time to inspect your outcome if it is what you want. So now that the meshes are aligned, we choose one to start for the cleaning up process. I wanted to start with the green one, but take a look, it's not selected in the tree. Visible is the green one, selected is the red one, I think. And now when I start to section, I sect out the red one, and I was a bit confused because now the red one is shown, but I didn't get the clue what I was doing. And so here you see one failure. Try to avoid it, it's annoying. So here I'm starting to see that something didn't work the way I wanted it to work out. And the second thing, in Cloud Compare, you cannot undo your operations. It does not alter the data on your hard drive if you don't save it. So you're safe with your data, but you can't go backwards. So if you do anything wrong, you have to delete it and load it new. So the best practice is to clone your meshes or your point clouds before you do any operations, and that's what I forgot here. So perfect example how not to do it, because that's extra work to do. But yeah, anyway, I proceeded for this time. But let's go on, and now I pressed the wrong button, and the wrong button again because I trashed the remaining mesh with the trash can, because you can sect in and sect out, and so I start over and speed it up for you to not bother you. But the sect tool is quite nice. You can select if you want to keep the selection or keep the surrounding, and when you hit OK, it makes a separate point cloud with the section and the remaining. But if you hit the trash bin, it trashes the remaining and just gives you leaves you with the selection. So be careful with this feature. It's nice if you don't need the things you've cut out, but be aware you can't bring them back. So now I have aligned it again, but it's not really 100% where it should be. So that's always good. For me personally, the colors, I like them, and switching between the meshes makes it really good to get an overview of the alignment could be right or not. So cleaning up the mesh with the section tool, I've sped it up again because this video is already too long, but I wanted for you my whole workflow. So it's not really the whole workflow, but I've included the main things that I did. So this is really the first try to get this right, and I have to say I'm relatively pleased with the outcome. It's not great, and it's not that what what I want to end with, but for reverse engineering it would be absolutely fine. And if you have some skills in MeshLab, Blender or similar software for touching up 3D models, it may be easy to get a good watertight printable model out of it. Or if you just wanna add something on top, you need the surface, or you need some inlays, or depends on your use case what you need the model for. And in my case, I want an as good as it can be model, because I'm lazy. I don't want to do the reverse engineering part. Also, I am right now on learning FreeCAD, and I'm not that good that I can reverse engineer such a part. So now I bring the fused point cloud into RevoScan again. Here you see it with the nice RGB colors. You can turn it off on the color tab, and that's what we're left with. And now we can clean up the isolations from RevoScan. Yeah, that looks about right. Also, the overlapping should have left this untouched and tried it, but I didn't double do all of this. But that looks quite good. So let's do the reconstruction. And let's see what we get. So here is the first model. Get rid of the holes. Here you can choose if the holes are flat or roundish. And I think again this does a really good job, RevoScan. But in this example I was not really pleased with the outcome of the model. I think the point cloud looked way better than the resulting meshed object. So back in Cloud Compare, I tried to mesh it in Cloud Compare with their Poisson reconstruct feature. And for this part, I have to say that the outcome from Cloud Compare is, in my opinion, better than the model from RevoScan. But take a look for yourself. Yeah, that's the top face. That's really ugly. I shouldn't have done the refinement. That was a bad decision. So yeah, that's what I had for my first results, and yeah, I think this is not printable, this is not usable, so I have to start over again. Not the data behind, it's not that bad, so let's try to fix it. I tried the other two parameters from the Poisson reconstruction. It gave slightly different results, but nothing really extraordinary. So that's the result without the refinement from Rivascan. That's quite good, but not good enough for us. So let's get started over again. Point cloud fusion. Look at the data. Here I added a new scan from the top. I didn't bother you with the scanning process because I think that's straightforward. You already know how this is working out. But I wanted a clean scan from the underneath without the base. So I scanned this and it turned out really good. And with this model, again, we are firing up Cloud Compare. Use our known meshes and add the new one. Yeah, I made 2 of them, so I can choose the better one. Rough alignment as before. Okay. Rename the reference as reference. Fine align the pre-aligned meshes and then align the new scan to the existing data. We use the same points again as before because they worked out great. Fine alignment done by the software. You have to play around with the percentage in the fine alignment, because if you have point clouds that share not 100% of the points, you have to go down with the percentage. So that looks way better than the first try. I think in this we have still a little gap. But overall way better than before. Cleaning up. And here you have this workflow. I cut out a section to get the view of the parts that I don't want. Then I can cut the parts that I don't want. I cut them out and section out, and when I'm happy I hit the trash bin and then I remerge the part with the remaining mesh, and then I can start over again, and so I can remove everything from the inside that I don't want without touching the pieces of the point cloud that I want to keep. And that's really nice because you have full control. Maybe it's a bit more work, but personally I like this even more than doing it in RiverScan with the feature of just selecting the facing points. So all the rough edges have to be trimmed because it was too much. You can go back, and if you go back you lose all made changes. So here you have an undo button. I tried the segment tool also because I'm not that familiar with Cloud Compare. This is all I learned myself here now, but it works really good, really great piece of software. In my opinion, better than the one or another paid software. I heard about Revopoint from Kickstarter, and I was with Revopoint from the Pop 1. I just missed the Pop 2. I was really excited about the Pop 1, and I had it at home, scanned a few things, and but that this time I didn't really have a use case where I would need a 3D scanner. That was just my interest and the playing around with this type of technical gadgets. But I was impressed of the performance, and again, there it was the first time I realized, yeah, it's a consumer grade scanner, and it does a decent job, but you cannot expect the same performance than you would from an industrial type. So I sold the Pop 1, then got the Mini. Was excited about the performance of the Mini and the resolution and the precision, but I didn't have the use case for it to really work with it. Then I tried it with the range, and I was impressed from the range, but I felt I missed the thing between the two, and that's where the Miraco came in handy. I tried a few scans with the range before in the industrial environment and get good results out of it. But as I mentioned before, the fiddling with the cable and the laptop or the handy or tablet, that was really inconvenient. And I liked the idea of all-in-one model that's working just like a smartphone or just like you're used to digital camera. And so I gave it a go, and I must say I'm really impressed. And all the upgrades and updates Revopoint brings to the software and to the hardware is really good. You can combine far and near mode, and you get really good results. You can do the whole processing on the scanner. It just takes a tad longer than on your desktop PC. So yeah, really they understood the needs of the customers and designed a product that's really good. And if we can get really good scans out of it and useful parts, well, amazing. So cleaning up the meshes is really time consuming, but you have to be as exact as possible. You will not delete any details you need for your finished mesh, but you also won't keep any parts that are unsharp or that have points sticking out where they don't belong to, because this will alter your mesh, and this is not what you want. So remove all of this noise, especially around the edges. And always try to keep the areas you need for later, as here the inside is really important, but all the surrounding, we can get rid of it. Okay, so these hidden points here, don't bother with them. Yeah, okay. Now they are here, I can get rid of them. They wouldn't have been too crucial, but yeah, let's remove them. So just get the view right, cut the portion you can get, and adjust the view. This is a really straightforward workflow, and it works really, really good. Got used to it, I think 2-3 minutes. Yeah, it starts to look clean now. So that was the hardest part here. The rest, to get it good, I cut sections out. And then in these sections I can remove what I don't need. I also thought about adding stickers or straps of sticky film on the sides to have marks for alignment, but I didn't do this. Maybe I could try it for another scan if this works better, because here you have very much noise to remove, which you don't need, but you need it for alignment purpose. So maybe with some tape or something else you could speed this process up, so you don't have to spend so much time in cleaning. And hopefully not every part is that complex for scanning. Because the big areas were scanned really good, but you have these details that you have also that you need, like this cylinders. If you could scale, if you just need the dimension and the top surface, you could always just scan it and scale it to size and be happy with it. But if you really want to reproduce the part or put it into a reverse engineering workflow, it should be as accurate as possible. And for that reason I made this, because I want to scan the parts now, and when I'm familiar with FreeCAD I will do the reverse engineering later, so I can repair the parts and afterwards I can reconstruct them for 3D printing or for forged carbon, something like that. The reason why I need these parts is I own Yamaha GTS 1000. It's a bicycle from 1995, and the plastic gets old and starts to break, and so I have to find something to repair it, and I don't want to stick glue to it and repair it that way. So as I own 1, 2, 3, 4 scanners, I should be able to scan it and make my own new parts. And the motorbike is relatively seldom. It's not easy to find used parts, and if you find used parts, they are in the same condition as yours. So really being able to making own parts, new parts, would be a huge benefit. So that's the main reason why I put this effort in this small part, and because I want to get used to the scanning workflow. So here you see it's pretty damn good, but we are not quite right in the back. There is, I think, not only a misalignment, but I think here we have accuracy problem. I think one scan is a bit wider than the others. Don't know why. Maybe I touched the surface when I scanned the parts and something moved a bit. I'm really unsure. So after meshing, the outcome is really good. So overall the mesh quality is great, I think, but at the back we have this misalignment that I don't like. So that's not good enough for me. And also the cylinders are not round. Here we are missing detail, and I think that's the limitation of the far mode, or we had to make more scans from the back. But I think that's, yeah, what we can get of the far mode. We can improve it a bit, but I think that's it. So, what do we do now? Yeah, I looked if I can correct it, but I wasn't able to align it better. So I have to stick with this at the moment. Trying to mesh it in RevoScan gave me a result that was not better. It was worse in my opinion. But I think that's for this type of workflow. Maybe I would have been able to do it better in RevoScan. You could do the whole process of aligning and cleaning all in RevoScan, but as I mentioned before, I think the alignment function in Cloud Compare is way better than the one in RevoScan. I stick with this workflow, and the cleaning doesn't make a huge difference. But the possibility of another tool for doing the meshing is great. But yeah, here I measured the thickness of the fins, and they are way too thick because the original part has 1 millimeter thickness, and here we are over 2 mils. So I decided that's not the way I want to go. So I put down some crumpled paper and the figurines from Revopoint and fired up the Miraco in near mode and feature mode to see if I can get it better with near mode and feature mode. Just a try. And I missed to record the first scan of the underside. That went really good because of the fins and the different spacings between the fins, so I had zero issues with tracking. The top is a bit more challenging because it's an even surface with really only a few details, but it worked out really good. As you can see here, I went with auto exposure. That was not the best choice, I think. And as you see here, if you lose tracking, you can always go back now until you have you got rid of all misaligned pieces, and you start again on a known location. The only problem I found is if you are exceeding 2000 frames, I have a hard time to find the tracking again, and sometimes it's stuck on a false tracking, and it always keeps on scanning in the wrong direction, so or in the wrong place, and it turns green and it thinks it's there where it should belong. That's a bit weird, but yeah, you always have the plus to start a new scan and merge them. It shouldn't be big of an issue. Maybe that's some software limitation, or I don't know. As I said, that's not the first revision of the software, and I think it won't be the last. The guys from Revopoint are working hard to get it good, and for now they did a decent job. It's really a usable device. You can really do good scans of objects that are good to scan. So many features, bright colors, best thing is white, matte finish, and you're good to go. And you get really accurate scans. I did an accuracy test. Maybe I will do this again later. And I was not sure what's more accurate, my caliper or the Revopoint, because yeah, I'm not able to measure in hundreds of millimeters. So I will do this again with a micrometer, and I'll let you know. But for this time I was really impressed. So again, let's fire up the PC, import the files, fuse the point cloud, same workflow as before. Just roughly clean it up. So again, here I pressed the wrong button and had to do it all over again. This time I used the isolation feature to get rid of the isolated points. What you see here is the mesh is quite finer. Export the point cloud. You see the holes in the groove. They are really there. So next model. This is the scan from the underside. You see you can also spot the ABS written on the plastic. So this is really great detail. Again, fire up Cloud Compare. Open up the point clouds. Apply all. Turn on the normals. Move and rotate. For each part, separate them. Yeah. Select the tool. So, looks promising. Rename the reference path as reference and start aligning. Now here you can see I pick about the same points as before. As I said, you need consistent points, and sometimes Cloud Compare does it not the right way, but yeah, just start over again. So start again, pick the points, and here you see you can increase the point size. Now you can see where you're clicking. You can do the alignment much better. Also the pin as before, pin as before, and in the middle hit the line and voila, looks good. So mark the two, find a line, and now you have to play with the percentage because they are not 100% same pixels. You want to go down as far that your alignment works good. So hit OK, check it, and this looks not right. You can see the groove here. The back, the pin looks good, but the front is not that good. So hit it again, change the settings, try it with the normals, hit OK, double check. Nope, that's worse. And again. Turn down the percentage, hit OK, double check, and that looks about right. So not rotate, it's the wrong tool. Looking from the side. From behind. From the other side. Again, ignore the normals, turn down the percentage. Take another look. And I think now we are pleased. That looks spot on. Yep. As I can see, that's good to go. Okay, so the next two, same procedure. Picking the points. Four at a time. Hit the align button. And voila. Fine align with the same settings as before. Hit OK. Take a look. And be stunned. For me this looks perfect. So again, cleaning up the meshes. Again, I sped it up because you already know how the process works, but I wanted to share it for you that you can see how much work I put into this model. You can skip the process if you like. You've already seen me doing it. But I wanted it to be included so that no questions are left. So, cleaning up the inside as before, section out, fuse again, section out, remove the unwanted pieces, fuse again, section out, remove. Always be careful not to remove too much, because then you have to go back a step. I think here I cut out a bit of the actual part. Yeah, here. Yeah, go back. Away you go. Section, remove, fuse again, just take care that you don't lose track of what you're doing here, because if it's a complex area you'll tend to get a good amount of cuts and just double check what you have to cut and what not. So that's the cleaned up mesh. Now clone these. Always clone. Hide the others. Now we can merge them. And from the merged we can create a mesh. Try it in Cloud Compare. The inbuilt meshing Poisson reconstruction. So here's the model from Cloud Compare, and I have to say it's really good. It's way better than before, but we have some artifacts, and the edges are relatively rough. So we could do the scans again and try to get better coverage, or combine more scans. But overall, this is really good detail. It's a really nice looking mesh. And what we can do also is we can bring it into RevoScan and try to process it there. And that's what we do here. That was the first attempt. It was okay, but not perfect. I have this artifact inside, so we go over again the cleaning. I think I did something wrong in the cleaning process, so I started over again. Spit it up for you. And indeed there was some left over, and so I spent more time in cleaning and looked to make it really good to get the best result out of the reconstruction. You see here the tiny bits, and what you can see that are distorting the scan. Also here getting a nice edge, sticking it together again, and also the top part again, making it better. Getting rid of all unwanted areas. And I think here I did it wrong in the first try. This is difficult here. The points that are so near attached to the surface, I can't get rid of them completely, but it should be good enough. Again, section out, delete, fuse again. Really easy. Bit time consuming, but easy, and you get a really good point cloud afterwards. You have really good control over everything you do. And it's also great because you can cut sections, you can cut it and bring it into your construction software, FreeCAD, Fusion, and you can use cross sections for constructing your geometries. Because when you cut the section out and you import it into your CAD software, it stays where it should be, and so you have references for your points. You can build up your part from these single cuts and make a solid part out of it. It's one easy way to do it without the need of expensive software as the size reconstruct or quick surface or something else. So here we are, and we get rid of this. Here is something we overlooked. Cutting it out, having a look again, and there is something more. And yeah, I think we got it. Let's take a look. Yeah, perfect. So that's our finished point cloud. Exported as PLY. Binary, of course, because we have only limited space available, and imported into Revoscan. This import. Okay. Wait a second, or 5, or 10, but it's absolutely worth your time. Yeah, and now I forgot to turn off the RGB mode. You can't see anything here. It would be just a click on the 3 balls on the top right corner. But anyway, I started reconstruction. Now I turned off RGB mode, and here you see the model. That's awesome detail. That's really great. No cut edges, really sharp edges on the underside here. The hole, really beautiful. Some holes on the bottom, but we'll get rid of them with the built-in tools. I'll speed this up again. I tried to fill the holes, the flat ones with the flat setting, and the rounded with the rounded setting, and all the other small holes at the end I take them with the rounded option, and I just mark all of them, and then we should have a watertight model. So that should be really good enough, because in these edges, these corners, I don't care how these holes look like. But here in this corner I used the straight hole filling first, and it was not that good, so I've redone it with the rounded. Then I used the remaining 2 holes you can see here with the flat. That's a bit time consuming. That's a thing that could be made better, because when I fill 2 holes it must not recalculate the other holes. But yeah, that's software side, and I think that will be fixed. So all the holes are filled, and I'm really pleased with this model. This is really great. I like it. That's what I hoped for, but never expected. And yeah, I've done it my own without any help from anyone other or any really expensive hard or software. Let me know your opinion. Is it as good as it can be? Could I have done something better? Just tell me. I'm always happy to hear your thoughts. And yeah, now you can do whatever you like with this model. Export it as STL, OBJ, WTF, and put it into Blender, send it to your printer, send it anywhere else to get it injection molded, get it CNC milled out of aluminum, whatever you like. Yeah, I tell you, I'm really happy about this outcome. And yeah, as I mentioned before, that's the work of a week. Yeah. Nearly. So, import STL, search the destination, and voila, bada boom, bada bang. Here we are. Zooming a bit out so you can see the part. That's it. So, thank you all. I hope it was not too long. And yeah, see you.